This lesson will serve as an overview of the spanning tree protocol on Arista switches. Arista switches provide several spanning tree modes, including rapid spanning tree, RSTP, rapid per VLAN spanning tree, rapid PVST, and multiple spanning tree, or MST. As I'm sure you are aware, Spanning Tree is a Layer 2 protocol that has been around for quite some time. Its purpose is to ensure a loop-free topology for our bridged Ethernet networks. We can take a look at our Spanning Tree mode here on Leaf 3 in the lab. Config, enter, and then we can see our Spanning Tree mode options with the command spanning-tree space mode and then a question mark. And we see we have backup, MSTP, none to disable spanning tree, rapid PVST, and RSTP, or rapid spanning tree protocol. The choice of spanning tree modes on Arista switches was originally done purposely to leverage enhancements over the original 802.1d standard. It has been my experience that rapid spanning tree is one of the most commonly deployed modes, but your mileage may vary. RSTP is defined by the IEEE standard 802.1w. Rapid Spanning Tree, or 802.1w, provides some enhancements over the original 802.1d standard. Namely, 802.1d was often accused of providing too slow a convergence after a topology change, and the whole network was represented by and governed by a single instance of the Spanning Tree protocol. Making a change in one VLAN, or area of the network, meant that TCNs, topology change notifications, had to be propagated through the whole LAN network. Rapid PVST, or Rapid Per VLAN Spanning Tree, provides enhancements over the original 802.1d standard in that Rapid PVST provides one instance of the Spanning Tree protocol per VLAN. MST, or Multiple Spanning Tree Protocol, gets its name because it provides multiple spanning tree instances. A bit different from Rapid Spanning Tree, MST allows for an instance to carry multiple VLANs. Convergence is much faster with MST than the original 802.1d, and some fault isolation in that failure of one instance does not impact other MST instances. On Arista switches, MST is the default spanning tree mode. While there is full interoperability, you may not be expecting to see MST as the default, so be sure to take this into consideration prior to deploying Arista switches into your existing network. Arista spanning tree implementation should be what you've come to expect with STP. For instance, here's a lab example of a switch running MST, the Arista default. Get out of config mode by typing end, and then we can type show run pipe include SPANN, short for spanning tree. And we see here in the output spanning tree mode MSTP. We can also issue the command show spanning-tree, enter, and see in this output that we're running MST instance 0. The spanning tree enabled protocol is MSTP. Another option would be to do a show spanning-tree and then focus in on one VLAN, for instance, VLAN 34. In the output, you can see that this switch is running multiple spanning tree with the root of VLAN 34 listed first in the output. We can see the root of VLAN 34 has a priority of 32,768, and the switch we are on is the root of VLAN 34. Arista switches create and process BPDUs as the industry standard outlines. You will find configuration BPDUs, topology change notifications, or TCNs, and topology change acknowledgements, or TCAs, all flying around as part of the operation of Spanning Tree. While we won't cover the details of all of the Spanning Tree modes, we will cover MST a bit since it may be new to you. For MST, there are MST instances, and each MST instance is assigned an instance number. The range is from 0 to 4094. So here in our output, you can see that VLAN 34 is part of MST instance 0. In an MST region, you'll find two types of MST instances. One is the IST, or internal spanning tree instance, which is set to 0 and is the default for an MST region. which is what we have here in this case with the MST0 for VLAN 34. All VLANs not otherwise assigned to an instance reside in the IST. The other type of MST instance is the MSTIs, or multiple spanning tree instances. These are where you assign VLANs, moving them out of instance 0. There also exists the concept of root bridges. A root bridge is considered to be the center of the spanning tree domain. And here in our output, you can see our root ID with the priority, the address, and that this switch that we're currently logged into is the root bridge for VLAN 34. Assignment of the root bridge is based upon an election process where the switch with the lowest bridge ID wins the election. There are also port types and link types. We can see in our output here that interface port channel 34 is listed as a normal port type in that it doesn't have anything besides the PDP reference, where other options include network and edge. We could also just simply issue the command show spanning tree and see port channel 4 and port channel 34, where in this case, port channel 4 is a P2B edge type. Another useful command is to show spanning-tree MST, enter. The output gives us a nice summary view of several pieces of information we may be looking for when digging into our MST deployment. And if we need more information, we can also use the command show spanning-tree MST and then the detail keyword. And here, obviously, there's much more detail given under each one of the interfaces, in this case, port channel 4 and port channel 34. We have another lesson that covers some configuration options and features.